All right, Math 1, Part 3 of 3.4. This is kind of like the, I don't know what to call them. They're just kind of like the strange special cases in which the same number is involved in both inequalities. All right, so we could call these same number special cases just to be, I don't know, whatever. so check this out. When I say x is less than 2 and x is greater than 2, what I'm asking you guys to do is find, all right, graph the shared solutions, all right? Where do these two graphs overlap? These shared solutions. So if I were to graph these on the same number line, 1, 2, 3, I'm going to graph x is less than 2 in red, and I'm going to put it above the number line so I can see it a little bit better. Here's x is less than 2 on the number line. Here's x is greater than 2 on the number line. So, what do they share? Well, the only place where I see red and black overlapping in this is maybe at 2. But we have open circles both at 2. If they're both open circles, they are not existing there. They actually don't share 2. They don't share anything. It's no solution. So if you see something like this, it's a no solution scenario. And of course, the graph for no solution is going to be empty set. I'll just leave the graphs alone on these, though, just for time purposes. Actually, no. Let's be thorough. So this would be the empty set. Dun, 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 dun. Empty set. All right. What happens if they're both equal to's? What do they share? Because it's and, of course. Well, I'm going to go out to 1, 2, 3. I'm going to put a closed circle at 3 for my black ink. X is less than or equal to 3. For my red ink, I'm going to go x is greater than or equal to 3. Since they're both closed circles at 3, but they're going in opposite directions, they actually do share x equals 3. So where's my green marker? They share x equals 3. So this is really strange for the inequality set. We actually have an equation as our solution now. It's not an inequality. They share x equals 3. So my answer is x equals 3. Interesting. How do I graph that on a number line? Well, I would go out to 1, 2, 3. And I'd put a closed dot on 3. There's my graph. Okay, that was strange. Now, what happens if one is open and one is closed? What do these two share? Well, if I were to graph both of them, again, on the number line, -1, 2, 3, 4, 5, maybe 1, 2 over here. We'll say in red ink is x is less than -4. In black ink is x is greater than or equal to -4. So what do you guys think? The only place where they could potentially overlap is at -4. One of them's open, one of them's closed. Do they share that spot? They do not. So that one's no solution. Wow. So we have one no solution over here, one solution over there. Again, it's the empty set. We'll be thorough and graph the empty set. Now, think about this. Look at 12. It's like the identical scenario to what you just saw. Do you think that one's going to be no solution too? Let's check it out. Since it's and, we ask ourselves, what do they share? In red ink, I'm going to go less. That's not red. Less than or equal to 0. In black, I'm going to go x is greater than 0. Hey, look, it's the exact same situation. So that means it's also going to be no solution. They do not share x equals 0. So it's no solution. So that's interesting. Of all the same number and special cases, same number and special cases, only one of them gives us a solution. And that's the solution, the actual number itself. All right, what do the ors look like? Well, remember, this means graph every element of both sets. Graph every element of each set. Graph every element of each set. Graph every, I know, I'm hammering it home. This is like Thor style hammering it home, guys. I just want this to be absolutely clear. Graph every element of each set. Oh man, I messed that one up. Okay, so our first graph on the number line. Man, I did that twice. All right, in red ink, I'm going to go x is less than 2. In black ink, I'm going to go x is greater than 2. It's not what they share, but the elements of each solution set. So, everything in red is good. Everything in black is good. At 2, though, nobody is occupying the spot. Nobody lives at x equals 2. So this is an interesting situation. All the solutions are present, all real numbers, except 2 is the solution. So here's how we would make that conclusion. The solution, all real numbers except x equals 2. Except x can't be 2. I'm going to put that. Except x can't be 2. So there's my solution. What would that look like on a number line? Well, it would look like our squiggle set. Remember, all real numbers, except there's going to be an open circle at 2, but then it continues right on after that. Let's check out the next one. 3, 6, 9. All right, in red ink, I'm going to go x is greater than or equal to 3. In black ink, I'm going to go x is less than or equal to 3. The question is, what would best represent all elements of the solution set? Well, everybody from negative infinity to infinity, including 3, because there's a closed circle represented at 3. So this one, all real numbers. Sorry, let's keep consistent here in green. Our solution, all real numbers. And you guys know how to graph that. Next one. X is less than negative 4. In red, x is greater than or equal to negative 4 in black. So your question is, it seems like we're seeing a pattern, right? For the or statements that have the same number, all real numbers has been included every single time. The question is, at the point at which they're going away from each other, we call that an emanating point. Is somebody living there? Does somebody live at x equals negative 4? Yes. All right, it's not green, but that's okay. Somebody lives at x equals negative 4, which means no solution, or not no solution. All real numbers is going to be our conclusion, including negative 4. So the solution, all real numbers, including negative 4. So I don't have to say including negative 4, but just for the notes purposes, it is all real numbers, including negative 4. All real numbers, period. Same graph. Okay, last one. It's just like number 15. In red ink, we're less than or equal to 0. In black ink, we're greater than 0. Somebody lives at x equals 0. It's the red dot. So the solution is all real numbers. All right, you guys did awesome, okay? That's 35 solid minutes of notes, but I think I got across everything I wanted to. So yeah, thank you guys for watching all the way through. Just to see who actually watched the video all the way through, I want you guys to put the word hamster at the bottom of your homework for 3.4. I just want to see who watched the videos all the way through. Okay? Hamster. See ya.